So this is the promised video. My plan is that you guys will do this bottom half with me. Use it as a guide to do the top half. When you turn in the top half, I will use it as a makeup up to 10 out of 12 on your previous quiz. Needs to be done by Tuesday when you come into class. So once again, you're doing the top half. I'm going to let you use the bottom half as an example. All right, so I'm going to try and ask questions as I go, and it's going to take a little while. You can always fast forward if you need to or want to. But I'm going to try and be thorough, so I'm expecting a 20-minute overview here. We'll see if I'm right. So we have 45 centigrams of lead to cubic meters in the first one. So I look at, when I'm thinking about these things, I look at this number, and I notice that there's no unit on the bottom, as opposed to this number in problem number 2, where there's a top and a bottom to the units. I also notice that this is measured in centigrams, and centigrams are a unit of what? So what do they measure? I'm hoping you said mass. And we're looking to find cubic meters. So cubic meters means m to the third power. If I draw a picture for you, this is a cube, and if it's a cubic meter, then it's 1 meter on each side. So we're wondering how many cubic meters would this 45 centigrams occupy. My guess is the answer is going to be significantly less than 1, because 45 centigrams is only 45 hundredths of a gram, so it's not very much. All right, so we're going to change mass to volume. So anytime that you're changing mass into volume, you need to use the density. The density includes both mass and volume. All right, so let's go ahead and begin. Well, since there's no bottom to the unit, we just write what we're given, 45.0 centigrams. Remember that 45.0 and 45 do not mean the same thing. All right, since the density is given in grams per cubic centimeter, the implication is that we should change centigrams into grams. So what would need to go on the bottom of this ratio? Since centigrams are here, they need to go on the bottom so that they cancel. They need to be opposite. And on the top, we can put grams. Now, just as an aside, like down here, if you're going from micrograms to milligrams, you would want to go to grams first and then to milligrams. But this problem only requires one step for the first part of the problem, just to get to the base unit. Just one step to the base unit. Base unit means the unit without a prefix. Now, we need to get rid of grams. So when we know that there's 11.3 grams equal to 1 cubic centimeter, so I'm going to need to put grams where it would cancel. Would that be on the bottom or would that be on the top? Well, since grams are here, we need to put them opposite. They have to go on the bottom. Then we put our cubic centimeters on the top. Well, it tells us in the density that 11.3 grams is the same as 1 cubic centimeter. Since there's no number in front of this cubic centimeter, that means there's just 1. So 11.3 grams is equal to 1 cubic centimeter. Remember that in these ratios, the top and the bottom have to equal each other. All right. The last step on this one would be to change from cubic centimeters to cubic meters. So since cubic centimeters are here, they need to go on the bottom, and on the top you put cubic meters. So see, our units are all canceled. The centigrams cancel centigrams, the grams cancel the grams, the cubic centimeters cancel the cubic centimeters, and we're left with cubic meters. We still, however, need to put our numbers in. So this is off of your things sheet. We know that 1 gram is 100 centigrams. Remember that centi has something to do with centuries, which is 100. We also know that a cubic meter is bigger than a cubic centimeter. So 1 cubic meter is some number of cubic centimeters. We know that a meter is 100 centimeters, but this is a cubic meter. So it is 100 centimeters wide, 100 centimeters deep, and 100 centimeters tall. So we have to multiply length times width times height, or 100 times 100 times 100, which is 1,000,000. All right, now I think we're ready to do the math. So I'm going to step up and grab a calculator here. Try and get my screen so you can see it. So I have 45. I'm going to multiply by every number that I see on the top, but there's only ones on the top. So it's really just going to be 45, and then I'm going to divide by every number that I see on the bottom. So divide by 100, divide again by 11.3, divide again by 1,000,000. Remember, you can type in 1,000,000 by using the EXP key. So it'd be 1 EXP. Notice that the little E popped up, which means times 10, and then a 6. So that means 1 times 10 to the 6th, like that. So our final answer, it's a big old number. So you have 3.9823, and then it says times 10 to the -8th. I told you it was going to be less than 1 significantly. All right, so that's not really true, is it, all those numbers? So we have to look back and see how many significant digits are in the information that we used. So this number has 3 significant digits. Remember that a 0 at the end of a number is significant if there's a decimal anywhere in the number, and there is a decimal, so that's a significant 0. 3 significant digits in this measurement. And since these are definitions, this one and this one are definitions, they have infinite sig figs, so the answer needs to have 3. So we have to round off after the 8. So our final answer is 3.98 times 10 to the -8th. The unit would be cubic meters, so m to the 3rd power. All right, that's problem number 1. Problem number 2 has 2 parts in its unit. So you write both those parts down, 50.0 micrograms over centiliter. Now, you may remember me saying in class that you can decide whether you want to deal with the numerator first, that's the top, or the unit on the bottom, the denominator first. I like to deal with the numerator first, so that's what I'm going to do. So I'm going to try and cancel micrograms and convert it to milligrams. So think about going to the base unit and then go to the unit that you're looking for. So from micrograms to grams, from grams to milligrams. So I'm going to put micrograms here. I'm going to put milligrams here. Oops, can't do that. I said I was going to go to the base unit. So I'm going to put grams here. So if you find yourself doing this, that's okay if you know this relationship. But I think it's probably more straightforward to go to the base unit, which means the unit with no prefix. All right, so which is bigger, a gram or a microgram? A gram is. So it's 1 gram. It's 1,000,000 micrograms, and that's off your things list. That one thing is 1,000,000 micro things. All right, next step, you need to get rid of grams. So we put them on the bottom. They have to be opposite, and on the top you'll put milligrams. Then, which is bigger, a gram or a milligram? So a gram is. So it's 1, and then milli has something to do with millennium. It's 1,000. All right, at this point, I've canceled micrograms. Boom, they're gone. Grams, they're gone. I'm left with milligrams on top, and that's what I want, milligrams. On the bottom, I need kiloliters. So I have centiliters on the bottom. So I would go again from centiliters to liters and then liters to kiloliters. So 2 steps. If I want to cancel centiliters, where do they go? Top or bottom? Well, they're on the bottom here. So they need to go on top there. And what is that relationship? Well, which is bigger, a liter or a centiliter? Centi has something to do with 100. as you do these, work on knowing the units, not just looking them up, because the next quiz will be a no-note quiz. All right, so centiliters are gone. Now we need to get rid of liters. Well, they go on top or on the bottom? Well, they're on the bottom here, so they have to go opposite. So liters, and on the bottom would be kiloliters. So which is bigger, a kiloliter or a liter? Well, kilo things is 1,000 things off of your things list, or you might remember that by thinking about a 5K run that you may have seen advertised. 5Ks is kind of like 5 miles, but kilometers are not as long as miles, so I could do a 5K run easier than I could do a 5-mile run. Both of them would cause me some trouble. But anyway, a kiloliter is bigger than a liter. So one of these is 1,000 of those. All right, so now we need to do the math. We multiply everything across the top and divide by every number on the bottom. And remember, this is like an imaginary 1 under here, so the 50 is on the top, just like the 45 was on the top in problem number 1. So we have 50 multiplied by 1,000 by 100 by 1,000 times, I'm skipping the 1 because it's just 1. All right, so I get that number and I divide by 1,000,000. So I divide by, take that answer and divide by 1. If you're using your phone at home on these, this EXP key is an EE key. Maybe I'll do the next one on my phone so you can kind of see what it looks like on an iPhone. All right, so that answer is this number. Now, I quit paying attention while I was talking to you about the EE key, so I'm going to run through it one more time. So 50 times 1,000 times 100 times 1,000. Then I'm going to divide by 1,000,000. I thought I saw the wrong number pop up. So I'm going one more time. 50. Sometimes my calculator doesn't register a 0 when I hit it. All right, and then I divide that number by 1,000,000. So I get 5,000. Which doesn't sound right. Let's try that one more time. So 50 times I'm realizing you can't see the screen, times 1,000 times 100 times 1,000, and then I'm going to divide by 1,000,000. Oh, that is right. That's 1,000,000. Okay, so 1 EXP 6. 5,000 right. So 5,000. However, when we think about significant figures, there's a problem with that because this number has 3 significant figures, and that means our answer needs to have 3 significant figures since these are all definitions. So how do I write 5,000 with 3 significant figures? The best way there are a couple ways to do it, but the way that I want you to do it is use scientific notation. So do 5.00 times 10 to the 1, 2, 3, third power. And what that does is tell us that of these 3 zeros, the first 2 are significant, but the last one's not, because the zeros at the end of the number with a decimal are significant. And then, of course, the units would be milligrams over kiloliters, and here's why. So you have micrograms canceled, grams canceled, milligrams is left. Centiliters cancel, liters cancel, kiloliters is left. So those are our 2 units, milligrams over kiloliter. All right, that's the end of problem 2. Again, 3 sig figs because of the 3 sig figs here. Now problem 3. So we have 450. Again, is there 1 part to this or 2 part to the unit? 2 parts. So milligrams on top, cubic decimeters on the bottom. All right, this time I'm going to model solving the problem just by putting the units in before the numbers, then we'll come back and put the numbers in. So this is, again, I like dealing with the numerator first, so here we go. So we're going to change milligrams to centigrams, which means we're going to need to go to grams on the way. So we'll put milligrams on the bottom, grams on top. Then we know grams are going to have to go on the bottom, and centigrams on top. Now we have the numerator where we want it. Cubic decimeters and cubic centimeters. So we need to get rid of cubic decimeters. Where would they go? On top. And then we could put cubic centimeters on the bottom, but I'm going to go to the base unit, which is the plain meters cubed with no prefix. So then we need to know a relationship. We'll come back to that in a minute. Okay, so then we put meters cubed on top here because they're on the bottom, so we need to get rid of them. We don't want cubic meters on the bottom, we want cubic centimeters. So I can know a relationship between cubic meters and cubic centimeters, so we've been working with that quite a bit. All right, so we've set it up so that milligrams cancel, grams cancel, and we have centigrams on top, which is what we want. We set this up so cubic decimeters cancels. Now we're dealing with the denominator. It cancels out here, and we set it up equal to the base unit. The base unit cubic meters needs to be canceled here. We change it to cubic centimeters. So now we're home free. We just have to know the numbers. So which is bigger, a gram or a milligram? Grams are. So 1 gram is 1,000 milligrams from our things list. Which is bigger, a gram or a centigram? A gram is. So one of those is 100 of those. Which is bigger, a cubic decimeter or a cubic meter? You may remember the cubic decimeter is the thing that I filled with water the first time I was demonstrating this for you. It's this plastic box. Remember that plastic box I filled with water? That's a cubic decimeter. So cubic meters bigger, we've got to figure out how many cubic decimeters are in a cubic meter, so we go back up here to our picture. If it's 1 meter is 10 decimeters. So for the volume in cubic decimeters, it would be 10 this way, multiplied by 10 deep, and then multiplied by 10 high. So that's 1,000. 10 times 10 times 10. So now, which is big, we're ready for our last numerical relationship, and cubic meters are bigger than cubic centimeters. A cubic meter, kind of on the scale of your washing machine, and a cubic centimeter is the size of one dice. One of the dice that we played back on the first day of school with the petals around the rose. So that would be 1,000,000. And again, the reason it's 1,000,000 is because it's 100 this way, and 100 deep, and 100 tall, so it's 100 times 100 times 100, which is 10 to the 6th power, or 1,000,000. All right, let's check our units one more time. So milligrams cancels milligrams. Grams cancels grams. Centigrams are left, and that's what we want. Cubic decimeters cancels cubic decimeters. Cubic meters cancels cubic meters. And so now I have cubic centimeters on the bottom, and that's what we want. So all we have to do is the math. So we have 450 times 1, which I'm going to skip, times 100 times 1,000. So times 100 times 1,000. That's what the top is. Then I divide by 1,000. So divide by 1,000 because that's on the bottom. Divide by everything you see on the bottom. And then it's 1, 1. And that's really, then 1,000,000 is the only other number. So divide again by 1,000,000. Answer, 0.045. And the unit is centigrams per cubic meter. All right, let's check sig figs. This number has how many significant figures? There's no decimal, so it has 2, because zeros at the end are not significant unless there's a decimal. If there is a decimal, they are significant. That's why here there are 2 significant figures, but here there are 3 because the zero is at the end. That means our answer has to be limited to 2 significant figures because all of these are infinite in their definitions. So does this number have 2 significant figures in it? And the answer is yes, because zeros in the front are never significant, and that's the only zeros here. So not significant, 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 1, 2 sig figs. So that's the final answer. So I'm hoping that you can use the information here to work with problems up here. The relationships will be different, but the logic is pretty much the same. And I expect this to be turned in on Tuesday when you come into class. And I think that's all. Hope you're having a good weekend, having some pizza with friends, and doing some chemistry.